have a block of mass m on a horizontal frictionless surface, and these two springs, they are horizontally placed and this is their natural length. Now they are not stretched or compressed, and over here there is a mass m, k1 and k2, they are spring constants. Now what we do is we pull it in this direction, then they release it. So as a result, this starts oscillating. We intend to find out whether this is going to be SHM. If this is going to be SHM, then what is the time period for these oscillations? So what we do is we adhere to our basic method, basic approach. So first of all, we move it by a distance y. We can also compress it also, that is, doesn't matter. Or let's compress it. This time let's compress it. So when it goes from here to here, so as a result, these both the springs, they get compressed, right? So we have displaced the body. Now find the restoring force. If this is displacement is, we have compressed it by distance y, so this gets compressed. So as a result, this applies a force onto this block in this direction, that is k1 into y. This also gets compressed by the same distance y, so this will also apply a force onto this block in this direction as k2y. So the net force onto this in this direction is k1y plus k2y. This is a force, this is the net force in this direction, so is equal to mass into acceleration, or acceleration is equal to k1 plus k2 upon m into y. If we equate the two, m goes over here, so acceleration is k1 plus k2 upon m into y. This is constant, this is constant, this is constant. So over here we say acceleration proportional to y. We also see that is we have moved the body in this direction. Displacement is in this direction. This has got compressed. So displacement is in this direction. This has got compressed. So as a result, the restoring force is in this direction. So acceleration is in this direction. So acceleration and displacement, they are opposite directed. So we can say minus y. So this is necessary and sufficient condition to prove that this motion is SHM. So this is SHM. We can safely use t is equal to 2 pi y by a to find the time period. So t is equal to 2 pi y by a, if we see over here, y by a is equal to m upon k1 plus k2. So this comes upon m upon k1 plus k2, that is the time period of the oscillations in this case. Now in this question, instead of having two springs at one side, we have k1 spring over here, and over here the spring with the spring constant k2 is over here. This all the things, they are usual things, that is, this is a horizontal surface, frictionless surface. The springs, they are horizontal. This is a block and free to move in this direction. There is no damping. We wish to find out if this motion is SHM, and if this is SHM motion, what is the time period. So first what we do is we displace the body by distance y. Let's say we can move it anyway. Let's move it this way. So this is y, right? First step is done. We have moved from this from here to it has been moved from here, right? So now the second is we have to find the restoring force. So this gets compressed, this spring gets compressed, and this gets stretched. Compression in this is y and elongation in this y, obviously. So when this gets compressed, so this applies a force onto this in this direction. What is the force? k1 into y. This gets extended, so this spring tries to pull it this way because this has got stretched. So this tries to pull it once again this way in this direction with the force k2y. So once again we say that is the net force k1y plus k2y is the net restoring force which is trying to move the body towards its mean position. So k1y plus k2y is equal to m into acceleration. So acceleration is k1 plus k2 upon m into y. So once again acceleration proportional to y. We have moved in this direction. This has got compressed. This applies a force in this direction. This has got stretched. This also applies a force in this direction. Force into mass into acceleration. So acceleration is also in this direction. Displacement is in this direction. Acceleration in this direction. So acceleration is proportional minus y. So it means this is necessary and sufficient condition for SHM. So this is SHM. So that's why t is equal to 2 pi y by a we can safely use. So t is equal to 2 pi y by a. Y by a is m upon k1 plus k2. We get the same result as we have got when the combination was something like this, m, k1 and k2. If it is like this, many students, they jump to the answer, that is over here the rest everything will remain same, but the answer is going to be k1 minus k2. No, it is going to be k1 plus k2 itself. If you stick to the methods, it makes the things much easier. First is always displace the body by distance y, find the restoring force, Once you find the restoring force, put it is equal to mass into acceleration, you will get acceleration in terms of y. So if acceleration is proportional to minus y, this means this is simple harmonic motion, and over there you can use the formula t is equal to 2 pi square root of y by a, and you can get the time period. And if you are asked to find the linear frequency, this is 1 by t is the linear frequency of these oscillations.